Let's move on to the next function. Let's calculate the number of payments by using the p-duration function. This function is a twist on how to determine the number of payments. Instead of using the periodic payment amount in the calculation, p-duration uses the present value of the loan, the borrowed amount, and the future value of the loan. What you will have paid in total when the loan is paid off. This calculation is useful if and when you know just three pieces of information: the loan principal, annual interest rate, the amount paid back, the combined principal and interest. The result p-duration gives you is the number of periods based on the previously listed factors. Here's how to use it. First off, we input the three values we need. So let's begin here, and instead of NOP, let's insert the expected total amount. So let's call it expected total ETA. And maybe let's copy these over here. Okay. And the principal, let's say it's 10,000 euro. So the percent, let's say 10%, and the amount we expect to pay will be 1110 euro. No, 10 lost there. 10,000, 11,000. Yeah, okay. So let's change these into euros. Same over here. Okay, we begin with the function insertion. So p-duration, enter. Okay, let's edit this p-duration. So first off is the interest rate. So let's click on the interest rate, of course divided by 12. Next is the principal value, and last but not least, the estimated amount. So this shows us the amount of payments that we will be, actually the number of payments that we will be making. So amount of payments here. So it's around 13 payments, which would include few last payments to be a bit lower. So what I want you to do is use same function, but with different data. Let's say we want, let's copy these over here. Let's say we want 15,000 euro. And the interest rate would be 0.5, and the estimated amount we pay, let's say 20,000 euro. So I want you to use this data over here and input the answer into this cell. Let's remember that this was also your task, okay? And then in this cell, please input everything as I said before. I will not show you how to do this on this one, but you can always go back and observe over here just to validate the answer you give. So the proper answer is around 7 payments. Let's save this. Okay, let's move on. So next is calculating the interest rate. The rate function tells you what the interest rate is on a loan. This function is great for comparing loan offers. Although a loan offer will always include an interest rate, you may want to use Excel to double check and ensure that some other fees are not included. Then you can compare different loan scenarios to see which one offers the true lowest interest rate. I don't think anyone wants to pay more than they have to. Some lenders charge fees as well as annual interest rate. When these fees are figured in, the effective interest rate will be higher than the interest rate. You can use the rate function to determine the effective interest rate for a loan. If it's the same as the stated interest rate, then you know no fees are being added. The inputs for this function are the principal, the number of payments, and the fixed amount of the periodic payment. Here's how to use the rate function. So as I said, we need to input three things. First off is the principal. Second off is the number of payment periods. So let's say 36. Number of payment periods. Now the 36 in the beginning. Next off is the amount you will pay each month. So amount okay, let's just format this part. Great, and the principal, let's set it to 50,000 euro. The number of payment periods to 36, and amount you will pay each month, let's say 4,000 euro. Let's set this as euro, this is euro also. Okay, change the format, maybe this way faster. And over here, as we go through the rate function. Okay, so let's use the rate function. And first off, what you want to use is the number of payments. Next, we go to monthly payments. And last, we go to the principal. Just for you to know, there will be an error right now. How so? Well, first off, remember I was talking about the incoming and outgoing money. Well, what you pay is the outgoing money. So you're supposed to actually put in a minus here. And this will show you the percent of the payment you will make for this loan. So the rate function returns the interest rate per period. This number can be misleading. The periodic interest amount may be small enough that it is displayed as 0% if the formatting in the cell isn't set to display enough decimal points. Just to show you what I mean over here, let's change the monthly payment by 1,500 euro, of course minus, and see that the amount is pretty much okay, because if you use the 36 times 1,500 euro, you'll see that it's about 54,000. So the interest rate is 4,000 euro. But how to see the interest rate over here? Well, you can simply change the decrease decimal number. So you see that it's actually 0.42%. And that's basically it. Now, the rate function returns the interest rate per period. This number can be misleading. The periodic interest amount may be small enough that it is displayed as 0. To find out the annual rate, you simply need to take the number returned by the rate and multiply it by 12. So let's do it right now. So we take the number and multiply it by 12. And the answer is 5%. Of course, the number is right now, I've previously changed the format, so just please note that if you have a number like this or like this, it doesn't really matter, you just have to change the format. So the annual rate is actually 5%. And just to explain it, as an example, assume a loan principal of 15,000 euro with a monthly payment of 650 euro. The loan is to be paid off in 24 months. So the periodic interest rate is calculated with the rate function, and then the annual rate is calculated by multiplying the periodic interest rate by 12. So what I want you to do is actually do the equation for this. So it would be 15,000 euro, 24 months, and minus 640. So this would be euros, this would be the same. What I want you to do is first off to create the monthly payment and then the actual interest rate per year. So please do it now. And the answer is 0.19% and 2% yearly. So please come up with this answer and save the file. Let's save it. There are three optional arguments that we did not use in the rate function. So first off, the future value, the FV. The amount you want the loan to be worth at the end of its life. The default is 0. Type. This tells the function whether payments are applied at the end of period or beginning of period. A value of 0 indicates the end of period. A value of 1 indicates the beginning of the period. The default is 0. Guess. An estimate of what the interest rate should be. It is possible the function will need the value to determine a result. See Excel's help for the further information on this function. The default value is 0 for 10%. These optional arguments, when used, become the respective 4th, 5th, and 6th arguments. Now let's go over calculating the principal. The PV function tells you what the principal amount of loan is when you know the other loan factors, such as the interest rate and the number of payment periods. You can use PV to determine how much you can borrow when you already know how much you can pay each month and how long you can make payments. The inputs for this function are the interest rate, the number of payments periods, and the monthly payment amount. The interest rate used in the function is the periodic rate, not the annual rate. Here's how the PV function works. So first off, let's copy the annual interest rate. Then we need the number of payments per period. And lastly, periodic payment amount. Okay. So let's set the annual interest rate as for 0.2%. That's a bit too much. Let's say 2%, yeah. Now, number of payment periods, let's say 48 months. And periodic payment amount, 2,000 euros. Yeah, okay. And lastly, now we use the PV function equals PV to begin the function. Now we click where we entered the interest rate, and we have to remember to divide it by 12. Next off, we use the number of payments, and lastly the monthly amount we are willing to pay. Okay, let's use the proper currency, euro. So of course minus here, don't forget it because then your number will be wrong. So the amount of money we are able to loan is 92,000 euro. So as an example, assume for this, with these assumptions, the loan principal is 92,186.61 euro. Altering any of the parameters will cause PV to return a different amount of principal. For example, raising the interest rate to, let's say, 5% changes the amount to 86,000. Although you may often think of how much you're borrowing, having interest in the interest is just as important. You can use two optional arguments with this function, which is, as previously, future value, the amount you want to loan to be worth at the end of its life, the default is 0, and type. This value tells the function whether payments are applied at the end of the period or the beginning of the period. A value of 0 indicates the end of the period. A value of 1 indicates the beginning of the period. The default is, of course, 0. These optional arguments are respectively 5th and 6th in the numbering, so we would have to input 2 more arguments. So what I want you to do is recreate this table, recreate the amount exactly step by step as we did it. You probably already understand how functions work, so just achieve this amount for you to see, and just change the annual income rate as for 15%. Yes, this is set as currency for currently, so let's change this. Okay, leave this as 48. Over here, let's say you want 5,000 euro. Let's change the currency and change the formatting as general. Okay, so you want the results to be here. And also please make this one happen. So your answer should be 1,796,574.05 euros. Please note that I made an error again. Previously, there should be a minus in front of the 50,000 amount. Now, let's move on to a new topic, which is statistics. Of course, statistics regarding functions and how to use them. So I will mark this area in which we previously worked with a thick border, just to separate it from all the rest data. Let's write in financial and let's create a new sheet. That's right, let's rename it. And we will be working on sheet 2, and here we will input statistics. Great. Now, what do I mean by statistics? Well, technically, there are a few terms you have to understand. Well, are you at average height? Do you earn an average income? Are your children getting above average grades? There is more than a single way to determine the middle value from a group of values. There are actually 3 common statistical functions to describe the center value from a population of values. These are the mean, the median, and the mode. The term population refers to all possible measurements of data points, while the term sample refers to measurements of data points that actually have. For example, if you are conducting a survey of registered votes in London, the population is all registered voters in the state, while the sample is those voters who actually took the survey. Technically, the term average refers to the mean value, but in common language, average can also be used to mean the median or mode instead of the mean. This leads to all sorts of wonderful claims from adventurers and anyone else who wants to make a point. It's important to understand the difference between these terms. What is the mean? The mean is calculated value. It's the result of summing the values in a list of set of values and then dividing the sum by the number of values. For example, the average of numbers 1, 2, and 3. And from those 3, we do a sum. Let's mark these. And this sum, we actually have to divide by 3. And this result is the mean. Next, the median. The median is the middle value in a sorted list of values. If there is an odd number of items in the list, then the median is the actual middle value. In list with an even number of items, there is no actual middle value. In this case, the median is the mean of the two values in the middle. For example, the median of, let's say, numbers 1, 2, 3, 4, 5 is 3, because the middle value is 3. But if we add a 6 in here, you can see that we have an even number. So the median would be actually 3.5 because we have to add these two and divide them by 2. I'll just write this down. Next, the mode. Mode is the value that has the highest occurrence in a list of values. It may not exist. In the list of values of 1, 2, 3, 4, so let's write this down. There is no mode because each number is present the same number of times. In the list of numbers 1, 2, 2, 3, 4, the mode is 2 because it is used twice and the other numbers are used only once. Okay. Depending on the number you entered, the 3 results may be the same, but it is very unlikely, or about the same, or quite different. The mode function will have returned a NA error if there were no repeating values in your data. So basically, we will go through the average, the median, and the mode. But that will happen in the next lesson. So I would like to thank you very much for listening to me and going through the lesson 5. And let's save our work and hope to see you in lesson 6.